This facility right here is we're probably housing, I would say, upwards of 400 inmates here, I would guess. That's a guess. Plus staff. The second floor is all the sheriff's department. There's probably a couple hundred employees that are here during the day. So it's quite large. Flow rates are very high. They do shower here. They use a lot of water. It's a big facility. These are definitely our big salt users, is these buildings here. The 24/7 operations that house this one, Bradford Prairie. It's a nursing home setting. Those people don't go home. They're there all the time, always using water. We decided we would go with the biggest systems that we have in our facilities, which are the 4 biggest campus buildings, and they have large systems which are inefficient, older, and that's what drove us to do these buildings first, because we would see the biggest savings there. One of 4 facilities and 5 systems. The city-county building has 2 complete systems, and those are a pump system, so they were a little bit different, a little bit more of a unique scenario as we make the brine on a different location and physically pump it to a holding tank. So those are not representative of what we did in this instance. This instance is more along the lines of what we did at Verona, and we also did in the courthouse. Very typical brine tanks on site, and we just basically use system pressure to send it back to the tank. The first thing that was performed was an elution study, and the elution studies are done by the water softening company, and they test, when it's doing a regen, they test the brine, and they pick out the spot where the calcium ions start to drop off, but the sodium ions are still increasing, flushing out, and that's the part of the brine that they use. They use that part from that point to where both ions start to drop off completely, and that's considered the sweet brine. What they'll do then is, in the timing, in the controller, since they did the study, they know at what point in the regeneration cycle they can make the valve switch to catch that brine. They program it, the valve will modulate, and then that's when that brine will be sent back to the tank to be reused in another cycle. And then when it's out of that range, it will finish off the cycle by running the rest of it back down to the drain again, effectively reducing the amount of sodium we send down the drain. The system in general looks pretty much the same as it did before. However, these controllers here are brand new, and on all 4 tanks, the old controllers did not have the capability to control the valves, which actually divert the brine from going to drain versus back to the tank. So these were installed new. In this instance here, there was one other system that also had the same controller issue. The other 2 had these controllers already in place, did not need to have that happen. We also, in the back here, you can see that we have some 3-way diverting valves, and what those basically do is take the brine, and instead of dumping it to drain here, they send it back down this line, the portion that we're recovering, back to the individual brine tanks, which are over here. These brine tanks are also new, smaller in size, and they also have a bottom in them, whereas the old tanks did not, because we needed a brine recovery well. And so we now have a 30-inch diameter tank versus a 39. What we were told was we could save 25%, see a 25% salt reduction with this type of brine recovery project in this instance, just due to the fact that these tanks are so much larger and it's a more inefficient system. So we're hoping to see at least a 20% reduction in our salt usage. Those numbers will play out as we go through time. Smart Fund grant covered the cost of doing the project. We wrote for $30,000. It was $20,000 worth of work to the contractor. There was piping and then administrative costs with project management time And we are coming in well below budget on this one as well. So we won't even use up the entire 30. Payback in years is like 4 years payback on this project when it's all comes out. And that is even including for, I even took out for replacing parts and also doing elution studies every 2 years to make sure that the units stay in tune. You're supposed to do, your resin degrades over time, and if we continue to do elution studies every couple of years, we can make sure that we're still staying within the parameters that were set up initially for the brine recovery. Next, we're going to look at replacing some softeners in some of our smaller facilities, some of the outlying buildings, more of a residential type application on most of these. That will be equipment replacement, straight out equipment replacement. And in certain instances, there's softeners that were oversized for one reason or another. We're looking at flow rates, fixture counts, trying to get the right softener picked for the occupancy of the building. And if we can do that, we can get some more savings in sodium and chlorides, and hopefully keep working away at it. We have more facilities even after that. Some of them are newer, and maybe down the road we'll look at even moving into those. The facilities I'm referring to for the replacements are a lot smaller, mainly an office type setting, not really any showers, so to speak, more just labs and kitchen sinks, maybe a dishwasher, and so the water usage is much, much less. I think there's a lot of other options like the low salting units. They have low salting units now that are much more efficient. And from what I've been hearing, 40 to 50% more efficient than an older unit. That's probably the best way to go for a residential application. I know there's several different ways of saving salt, some more efficient than others or more cost savings than others. But a low salting unit is the way to go, more efficient softener. Consult with a professional, and they can give recommendations on the best unit that's out there for them. And from that point forward, you can move in and you can save a significant amount of salt just by replacing the whole unit, for sure.